My name's Jesse St. Laurent. I run product strategy for SimpliVity, and thanks everyone for coming. We're pretty excited. We're in a lot of our sessions, everybody's there because we're giving away a car today. This is the first session I've given today where no one's here to get a chance to win the car, which is cool. So I promise I'll go fast through company and we'll get into technical details. Founded in 2009. Interesting, we were 3 years in stealth. This is a hard problem. We tried to solve this with open source and tried to find ways to make this a simpler problem. Turns out we couldn't find ways to make this simpler. So we basically invented everything between NFS at the top of the stack and the OS at the bottom of the stack. Everything in between is RIP. Not necessarily what you look for, but that was how we got here. 12 patent applications to date, more if we would stop writing code and write more patents. Everyone's based in Boston, the whole company outside of our field folks. Investors, Acel, CRV, Kleiner. So what is it that we do? At the highest level, the objective is to collapse this stack that we see here. So we've been through 2 waves of consolidation if we look at recent open system space. We went through a wave of storage consolidation, get rid of the islands, collapse into a single shared resource pool. VMware gave us the same thing a decade or so back on the server side. Our objective is to take this typical data center stack of infrastructure, storage, servers, dedupe appliances, all this other stuff, and effectively collapse it vertically, right? So today, if you're not backing up to your backup dedupe device, the CPUs sit idle, right? Those are wasted resources. Part of the objective of virtualizing our infrastructure was to get rid of all those wasted resources. So that's what we do. We replace this stack, very simplistically, with what you see on the right-hand side in a scale-out way. So you just add systems into the environment and continue to scale out. The one caveat, on the WAN optimization side, we're not in the business of doing protocol optimization or playing games with Ethernet like the guys in that space do. Our objective in this, when we talk about WAN optimization, is reducing the amount of traffic that needs to be moved over the WAN, specifically for the purposes of storage traffic, not for your overall network traffic. And we do the objective, obviously, is to make it compelling for customers. So lower price, better performance, simplification of labor and management. We say 3x because we did this extremely long ITL analysis of all the tasks you need to do in a data center and which ones were likely to have mistakes. I actually think when you see the demo, hopefully you think it's a lot more than 3x, because we certainly do. A few vocabulary things. We talk about OmniCubes. These are the building blocks within our environment. SSD, hard drives. SVT is our virtual machine running in this environment that does all the services that we're talking about. And the VMs are just normal customer VMs. We unify these together when we put 2 or more in an environment, and we call that a federation. So a federation is just a collection of OmniCube systems. Continue to scale out horizontally, but the whole idea that you have to replace one device with a bigger device or put a second device next to it and they don't unify into a single pool, we think is broken. The objective here is plug it in, join the federation, and the environment continues to expand. That pool of resources continues to expand. At the other end of the spectrum, inevitably at some point you have to take gear out of your environment, whether it's because it's been 3 or 4 years and that's your cycle, or whether it's simply because you want to reduce the size of this data center and grow another. In our environment, we have a feature called evacuate. We can all make our evacuate jokes. The tell the system to evacuate. VMware does the work of moving the virtual machines. We pull all the storage off of that, balance it out into the rest of the environment, and you can pull that node out. So we allow you to scale out the environment as well as scale it back in, all without ever having to do manual data migrations, right? So the idea of storage migration should be gone. Yeah.
Is it a requirement for 10 gigabit, or is
it is
going, or is that? I mean, I know that's where the industry's going, but is that a requirement that it has to be that?
It is. So all of the rights into our. Sorry, I didn't mean to interrupt you.
No, I said 40 gig, not 10 gig.
Yeah, 40 gig. So the network for us, we access the network through vSphere. So whether it's 10 gig or 1 gig or 40 gig is effectively doesn't matter to us. We do mandate 10 gig though for the federation interconnect. So there's an interconnect where all your storage traffic moves over. That needs to be 10 gig. In small environments that have 2 nodes, so remote offices, branch offices, things like that, you direct connect the systems and you don't have to deal with any 10 gig switches. So we have twin ax cables, plug 2 systems into each other, you're off and running. And then 1 gig out the front for your VMs. In larger environments, plug them into a 10 gig switch. This is obviously a simplified version of this drawing. If you want to have redundancy and failover, or if you want to put everything through a 10 gig connection, that's all fine with us.
But remember that they're doing, if a node fails, the data has to be on another node, so it's synchronous replication for all the writes. 1 gig would get bottlenecked.
Oh,
really.
Yeah, 10 gig is critical. So every write into an OmniCube is persisted on 2 OmniCubes before we acknowledge to the VM. So you can sledgehammer 1 OmniCube, your VMs will restart someplace else.
Can we see a demo?
Life continues.
You
know, so we talked about doing this. I was lobbying for completely smashing an OmniCube and showing things continue to run.
Jesse, I have already proposed to Tom.
Smashing an OmniCube?
No. We take them out in the desert with thermite. I have the permits. I have talked to several vendors in the cluster. I have talked to several vendors in the clustered model.
That's how it has the permit. That's a scary thought.
So if we bring a generator and run some VMs in the middle of the desert, you'll blow up one of the OmniCubes.
And I will hire Ben to do the video.
It would be an excellent YouTube video. Yeah, so I'm all in favor. I don't own our marketing budget, so you'll have to talk with Tom about the practicality of that investment of a system, but we'll leave that to him. Was there another question? Sorry.
So can you talk about the difference between your federation and clustering?
Yeah, so we chose the word federation very intentionally because when you say grid and you say cluster and you say a bunch of these other terms, there's a whole lot of expectations that come with that. So we use the federation term because this environment is intentionally loosely coupled. So any given write has to go to 2 OmniCube systems. But what you don't want to do in a system that has deduplication, compression, optimization is try and build some Uber index that is truly encompassing of the entire environment. There's a scalability problem that prevents you from actually growing to scale. So the OmniCube systems as individual systems are very self-aware and know enough about the other OmniCubes in the environment to be very efficient in their communication. But what it means, when people think clustering, they tend to think, A fails to B, or there's this really tight coupling, and our coupling is looser than that to allow for the kinds of scale that we can deliver.
Don't some modern databases solve that problem?
So if there are customers who run applications that certainly have the horizontal scalability designed into them, what we find in the core data centers of our customers, so our business is running core business applications, right? Exchange, SQL, Oracle, SAP, right in the middle of the data center. None of those are particularly good at providing their own distributed storage and managing all that infrastructure. We provide, in this environment, we effectively replace the traditional storage infrastructure, but give you all the things that the applications depend on from a shared storage infrastructure.
So you acquired 10 gig.
Mm-hmm.
You suggest a minimum of 3 nodes.
Minimum of 1 node, actually.
Okay, but you said it multiplies to 2 others, replicates to 2 others if you have them.
A pair. So if you have 2 systems, or if you have more than 2 systems, it still only goes to 2 systems in the environment. Any write.
Do you have specific 10 gig lengths switches that you recommend for this?
No, I mean, as far as we're concerned, as long as you have a quality 10 gig switch underneath your infrastructure.
Quality means so many different things. So
it does.
What's the actual requirement? Is it low latency, or are you talking about 10 gig from port to port, or what?
So we run our testing with everything from, so I don't want to pick on any individual vendor's switches. We run high-quality 10 gig switches in our environment, non-blocking, not oversubscribed switches. We also do testing with switches that I wouldn't deploy in my production infrastructure that are blocking, that are dramatically oversubscribed. It depends. If you're going to drive the system so hard that you're hitting 10 gig limits, then you want to make sure you have a switch that can deal with that. In most production environments, especially in systems environments that have 2, 3, 4 nodes, the 10 gig limits aren't really the big deal for those customers, even if they're running not the lowest latency 10 gig switches.
What happens when you lose a node? So if a node fails, you need to copy the data on other nodes, and at which rate? Because I want to be sure in the shortest time possible.
Sure. So all the data within a given OmniCube is RAID protected from dual disk failure. So the objective is belt and suspenders, right? Core mission critical applications, data loss obviously is not acceptable, right? So within an OmniCube, the data is protected from dual disk failures. And then we also store that data across 2 separate OmniCube systems. So if you lose an OmniCube within your environment, one of 2 things have happened. One, you've kicked a power cord, you failed a power supply, whatever, or 2 power supplies, I guess, in this case. And you may not want to trigger a rebuild within your environment because in half an hour, you might just have a new power supply, or you might just be plugging it back in after you kick the cord. So in that case, there's no need to rebuild. If that node's being taken away permanently, or let's say you blew it up with thermite and you want to put another one into your environment, when you add that other system, it will rebalance the environment to that new node. And that runs as a lower priority I/O task to production I/O. The assumption within the environment is you already have dual disk protection on a single OmniCube. The highest priority thing is serving your production applications, not rebuilding so that you have the suspenders to hold up your belt. Did that answer your question?
Not really, because if I lose a node and I not be able to get it back in a certain amount of time, I need to rebalance of the cluster, and I need to know at which rate the data are moved all around to get the.
It's already mirrored before you get the I/O.
One time. One time. If you
But the second is lost within it.
If the second system with dual disk failure protection was also blown up with thermite before you did an entire rebuild, so we think, and that's certainly right. We're pretty far out on the standard deviation curve at that point. You know, you can lose entire data centers as well, and that's probably actually more likely than the scenario of a cascading failure of multiple systems. We think dual disk failure protection in 2 separate systems gives you sufficient protection, in fact, better than most other folks in the industry, even from a traditional storage perspective or any kind of distributed storage.
So what exactly is the SVT that's sitting inside of my ESXi box?
Yeah, so SVT is our virtual controller. It's a virtual machine running on the box that's delivering all the services that we talk about.
Storage.
Including what, I'm sorry?
Is it a VSA or?
So, yeah, the term VSA is, yeah, so.
Storage controller. It's a virtual storage
Let me put in,
Well,
right.
controller or data?
It's offering an NFS share to the local ESXi box
Okay.
that represents a data store.
Okay.
How
so
much
it's a
resources?
So it is a VSA, so it does do data.
Your word, not mine, but yeah.
It does
How
do
much?
data.
So the same reason we don't use cluster, we don't use the term VSA, right? There's these terms in the industry that are preloaded with expectations that if they're not true about us, we tend to be a little uncomfortable. Other people end up using them, we tend not to, but you can use it.
Actually tested this stuff with all the security controls in ESXi turned on.
So what specifically do you want us to turn on?
vShield app, data security, endpoint, all running inside that.
Yeah, so
I've
Lockdown
seen
mode as well.
in lockdown mode and everything enabled because that's the way people are telling people to enable it.
yeah, what percent of your customers deploy that way, do you think?
Just that word.
Quite a few. They're the ones I talk to deploy that.
Yeah.
I've seen drastic.
But then you're maybe in a specific.
It's a self-selecting
use-
audience to some
yes.
extent.
Banks.
Right, banks deploy that way.
Lockdown mode will be very standard. And
Yeah, so we've done a subset.
Not necessarily, because I came from that. We didn't use it.
Yeah.
That was
So I
the
think.
reason
I asked is we saw a market issue with performance on anything sharing up storage.
Sure.
Through the networking stack because it's getting, you can't get that stuff out of the way.
Yep. So what we've done to this
You
point
can't
is.
ignore it either.
Sure, I agree. And for the subset of customers that do that, we've tested some of those things today. We haven't tested every single product on at the same time that you just talked about. But as we see customers doing it, we'll expand the matrix, right?
A couple questions on the network side. Do you support VLAN tagging?
Yeah. So we sit above all that networking stuff. So effectively, we get NICs from VMware, and we can.
How about like Cisco 1000V or VMFlex?
Yeah. So we actually don't have those certified today, but you can bet that's on the short-term roadmap.
How do you integrate into existing environments?
You can be the straight person for my presentation.
Good job.
One of the things that's a classic mistake of emerging technologies is you assume the customer is going to love what you do and throw everything else out and adopt what you do. We think that's a terrible way to approach the market. The customer's got a data center full of server infrastructure and storage infrastructure as well. So we can take the data stores that we present to the local systems and present those same data stores out over NFS to the existing ESXi systems or new ESXi systems. So it allows us to extend that data store. Customer can storage VMotion into our data store, VMotion onto the box, no downtime. They're now deduplicated, compressed, and optimized within a SimpliVity box. Do you have another question? Because that works out perfectly. So the last step is cloud integration. So we connect to the cloud for the purposes of backups. So when we define a policy for protection of a VM, we can protect it out to the cloud. Today this runs in Amazon EC2. It's designed to be portable. That'll be a common theme as we talk about our architecture. So as there's market demand for other clouds, it's simple enough for us to move it. and we'll move to other cloud platforms as well. So today this is the same code that runs on an OmniCube. We actually call it the Omni Stack, which is basically all of our IP that you drop on top of a system to turn it into an OmniCube. That's the same thing that runs in EC2 today. It joins the federation, and you can define policy to move data back and forth.
So just for data, not for VMs?
It's just for data today. It's not for VMs. Is that a question, or is that?
No, no, no.
Do you have any NAS acceleration built in?
What do you mean by NAS acceleration?
There's some companies that do optimization of NAS traffic, caching, and RAM, and so forth.
Yeah, so I mean, that's the nature, that's sort of a sliver of what we do, right? So if you look at our system, we're designed to replace all of that type of infrastructure. So when we give sort of the propaganda-laden version of this presentation, it goes through all the devices in this environment and why they're not necessary. And one of the things is the need to accelerate your NAS infrastructure. If you have intelligent tiering and caching built into your platform natively, there shouldn't be a need for those devices in your environment. So yes, DRAM, flash, hard drives, moving data between them intelligently. Everything, remember, everything's deduplicated, compressed, and optimized. So when we move at a very fine grain level. So when we move data into the cache tier, we're only moving the hot few K up into that environment. Same thing for DRAM. So if you think of something like Bootstorm environment, where you have to boot 100 virtual machines at the same time. Last time I tested Windows, it was around 83 megabytes of reads, as I recall, it had to do. Call it 100 meg to make the math easier. If you boot 100 of those at the same time, it's 10 gig, if my quick mental math is right, of random reads off of traditional infrastructure. That's a lot of random reads to hit a storage device with. In our environment, all that data is deduplicated. You're going to end up with 100 megabytes of reads off the hard drives, worst case scenario. That's assuming it's not in memory and assuming it's not on the flash cache. And we're going to serve out 10 gig out the front end, but hitting those hard drives only for 100 megabytes. Hard drive IOPS are the most precious commodity in the system, and anything you can do to preserve those IOPS is a huge win. And that's part of the driver behind the inline duplication that we'll talk about. So I started talking about VM centricity a little bit. The whole idea of providing data stores in your environment and managing data stores we think is inherently broken. This is the way we do it because this is the history of storage. Right? No one, if you taught a class about VMware, but skipped all the storage, and at the end of the class you asked the person, now how would you interact with your storage? I would be willing to bet nobody who just learned about VMware would ever invent a data store. It's frankly a broken concept, right? It just doesn't make sense. What you end up with is if you have a green virtual machine here, can you tell that's green? In a traditional storage environment, you want to take a snapshot of that green VM. You get every VM that happens to be in the same LUN or shared, depending on whether you're NAS or SAN. And in this case, I guess that's 9 VMs that you weren't interested in. Now, if you do that once, it's probably not a big deal. But if you think about it over time, you don't want to restore off of tape. If you want to back up to tape for compliance or regulatory reasons, fine. But if you want to keep these for restore, once every 5 minutes, keep them for a couple hours. Once every hour, keep them for a couple days. Once every day, keep them for a couple months. Once every week, keep them for a few years. That's a lot of data that you actually didn't need. Even worse, when you move it over the wide area to replicate it to a secondary environment, you're burning bandwidth. And you're burning IOPS on the remote side for stuff that's not of value to you. So if you take out the traditional shared storage and we replace that with SimpliVity, we apply backup policy to individual virtual machines. Doesn't matter what data store it's in, doesn't matter where it's stored, the policy is applied to the individual VM. If I take a different virtual machine here, the purple VM, can have a completely different policy, both locally and remotely. So it doesn't matter whether they're in the same data store or different data store to us.
When you're talking about VM-centric, to be honest, I don't care about the VM. I care about the app. My app could be one VM, it could be a part of a VM, it could be 100 VMs.
Sure.
How can I define it as a policy for an app that it just figures out because ESXi knows all those communications? How do you define the app?
Sure. So
I'm not going to know the VMs that are under it. I may not know. I'm the backup guy. I don't care. It's an app.
yeah, so I have 2 comments on that. The first is we think the idea of a backup guy and the storage guy and the virtualization guy, actually maybe not the virtualization guy, is broken. And in organizations in a few years that still have that are going to be far behind the rest of the companies that have figured out that you need people that are horizontal that manage this in a very different way, right? So we think the backup guy is actually needs to learn the rest of the infrastructure. That said, it'd be a really logical feature for us to say support vApps so that you could apply this to an application and run the whole infrastructure.
And it's not all of it, because I could have multiple vApps that become part of the app.
Sure.
So how do I back up the app? VM-centric is just a lost cause.
So, so I'm curious, if you think VM-centric is a lost cause.
You know what's in the app in order to know what to back it up, because if I just back up 1/3 of the app, that's useless.
So if VM-centric is a lost cause, what does that mean backing up data stores is?
I want app-centric.
So I agree, directionally, that's great.
Yeah, where would they get that data to know what the app is?
Right, unless somebody can define what the application is, there's no construct to get that today.
You can use Structured Navigator, you can use VCOps,
Right.
you can use FAB, you can do a lot of different ways right now instead of vSphere to define an app.
So most of those products that you just mentioned define 5% or less of the market, right? The majority of the market isn't even using vApps or any of these other ideas. The very leading edge folks are, and we're excited about that. We'll innovate and make sure that we can back up their environments in more intelligent ways. The vast majority of the market today is struggling with the idea of tape and taking snapshots of LUNs and shares. We think taking the backups at the VM level is a pretty significant step forward for them. We think vApps are another pretty significant step forward, which for the record we don't do yet today, but it's a logical expectation. And as soon as there's more constructs that we can take advantage of, we'll do that. What we don't want to do, and this is, I didn't show the UI yet, but we are 100% embedded inside of Vcenter. Not because we think Vcenter is the world's best user interface, but we know that the VMware admin spends half their life in Vcenter. Right? What we found is 2 flat panels on every desktop, one of which had the browser and email, and the other of which had Vcenter. We embedded in that environment to prevent the user from having to leave, go to another interface, and define separate constructs. So we put everything on top of logical constructs that exist within the Vcenter environment. Use virtual machines, use data centers, use clusters. All those things exist without making the user have to define some new construct to manage their environment. So the objective is to overlay on top of that stuff. As soon as there's something else for us to overlay on to get that application without forcing the user to manage something else, we'll gladly do that.
So because of that integration, protection of the vCenter server itself, if it's a VM, still possible then?
It is. So we have that level of integration, but at the same time, we're not dependent on Vcenter for all those tasks. So there's some things, obviously, you need Vcenter for, right? We talk to Vcenter to get information about virtual machines, but the environment continues to run even if you lose your Vcenter environment.
The reason why I'm saying that is, like, say I just back up Vcenter. Where's its database? It's not sitting on the Vcenter server, so now I do back up the database, therefore I try to bring it back up, don't run. So I need to know all these components and know what is missing. And a backup solution is tied into ESX. Should be able to tell me that.
As soon as ESX can tell us that, we'll gladly layer on top of that.
Well, you know the networking pieces, you know what's connected to each other.
Yeah, so I guess there's probably some PhD out there who's trying to figure out for a project, based on the communication between certain VMs, that defines an application. Once it's productized, we'll gladly support it. So when you...
But Jesse, do you do consistency groups?
So today we don't.
Okay.
We do app consistency at the VM level using VSS. Right. vApps are the way for us to get to consistency groups. We talked about deduplication being a global construct for us. So when we replicate data from Tokyo to Boston in this case, let's say the green virtual machine was Windows 2012. The purple virtual machine is 2012 as well. The first time I move that purple virtual machine to Boston, all those Windows 2012 bits are deduplicated. I don't have to move them. So this is not deduplication within one tier of my environment. It's not deduplication within some subset or within one VM or within one volume. It's global within this environment. The other thing we do to optimize the transfer of data is there's certain things about your VM that you just don't need when you replicate them. The vSwap file is a perfect example. If you back up a vSwap file and then you restore that VM and you boot the VM, the first thing it does is delete the vSwap file and boot. So why capture the vSwap file? For us, we just take it out of the backup. No best practices of juggling, putting them in different data stores and hoping that after you're the consultant that set that up and you leave, that the customer can remember how to do that and continues to do it on an ongoing basis. Just simplify it, right? Our objective is, whenever possible, just to simplify the infrastructure for the user. So what we've done is we just drop that out. When you replicate, we don't replicate the vSwap file. And you can have a completely different policy on both sides of this environment. The last step here is the purple virtual machine in Tokyo. Because we're able to manage this entire environment at the VM level, we can move virtual machines as well. So I can take the purple virtual machine in Tokyo, shut it down, and do what we call a SimpliVity move. That'll take this virtual machine, unregister it from Vcenter, pull it out of the data store, inject it into a data store in Boston, register it on the Boston side. You have to clean up your network connections, and then you've moved a virtual machine from one data center to another. I think this is pretty cool. We actually presented to someone in the Boston area who moved a data center about 20 miles down the road, and they used traditional storage infrastructure and went through a whole lot of hurdles to figure out, this is the set of VMs I need to move this weekend, juggled them around, getting them all into the same data store, replicating the data store, getting them all out of the data store at the other end. It became this incredibly complicated process. When we presented this slide, I thought the person sitting on the other side of the table was actually going to cry. And it's always a risky thing when you're the presenter to ask if that's a good thing or if that's a bad thing. And I dove in head first and asked why the emotional response to the slide. And the person described the process they had gone through and basically said their last 6 months was this juggling of data to try and get their virtual machines moved 20 miles down the road. When they saw that this became right-click on the VM and say move, they were somewhat wishful that they had had this at the time.
Other ways to automate, like changing of IPs?
Yeah, so we don't fix the IPs on the remote side today, although it's a logical extension of the platform. You can, yeah, leave it at that.
Like, what's the difference between that and SRM?
Yeah, it's a good question. Is there another question?
That was the same question.
Okay. Skip the layer. Global unified management. I talked about being embedded in Vcenter and all the reasons we do that. This also is about our VM centricity. And the last step I didn't talk about here is when you define a policy, let's say you've got that virtual machine in San Francisco, you want to replicate it to London. Literally when we define that policy, it's how often do I take the backup, how long do I keep it for, and where do I send it? And where do I send it is not a LUN, a share, a controller, an IP. You don't even specify an OmniCube. You specify a data center. So send this backup to London. Again, the idea is to leverage the logical constructs that exist within the environment today so the customer doesn't have to think more than they need to. They know they want to send it to London, just let them pick it out of a pick list. So if the federation includes Tokyo, Amazon, South Africa, I guess in this drawing, San Francisco, and London, they get a list that contains all those potential destinations automatically. They just pick one and the backup goes. Deduplicated, compressed, and optimized. What that means is in the London data center, I can go into that environment. I knew I was going to trip over that eventually. I can go into the London data center and swap out the entire underlying hardware infrastructure without ever having to do any manual data migrations of that environment. So I go in, add 2 new OmniCube systems into the federation, evacuate the 3 old ones, and during that process, VMware allowed me to do a VMotion to move the VMs. Our evacuate moves the data off the old systems onto the new systems, so no manual migration. And then all of the policies were defined to point to London. So all of those inbound and outbound replication and backup jobs continued to run through that entire process. And when I was done, I didn't have to reconfigure any of them. So this whole idea that the biggest work with a storage deployment is day 1, we think the biggest work is day N, right? When you go to take that thing out of your environment, that's actually when you experience the most pain. We talked to a customer who does 3 months to get their array in and 3 months to get it out to deal with migration on both ends of the environment. This is remove, the data flows, no policies need to be updated, nothing needs to be moved manually.
Given everything that's happening in the U.S. and around the world with data movement between countries,
yeah.
How do you prevent it?
But how do I prevent the data from moving? So
put a box on the other side. I mean,
no, you're doing it already. Now you have a policy change. How am I going to go into SimpliVity and say, don't allow that anymore?
So you say, how do I make sure data doesn't go to London?
Yeah.
I don't define a policy to send data to London.
Don't define the policy.
You have complete control. We don't move data without you telling us to move data. If you want to say, you know what, I don't want to send data to the U.S. anymore because the NSA reads all my data, then turn off those policies. I met with a company from from Europe recently who, when we showed the example of Amazon, they said, what other clouds do you provide that the NSA doesn't read? Right, so we can all make our jokes, but yeah, it's as simple as just not defining a policy to send data there. We're not going to send data any place unless you tell us to put it there.
Or a court order. Or a court order.
Yeah, I mean, the classic, if somebody shows up and subpoenas your systems, that's a separate problem.
Yeah, they can't change the legal system, and they can't change the policies that you put into place on your equipment.
Right.
Yeah, but if you really wanted to make sure that an administrator never sent data from from Europe to the U.S., you just create 2 separate federations, and then the U.S. locations won't show up in the UI to move it to.
Yeah, the objective in unifying all this is to allow that data to move. If you don't want it to move, don't unify Europe with the U.S. It's simple enough.
You define a federation as a set of data centers, and if you just never want data to move from point A to point B, put them in separate
just don't join it. So we think that's a pretty significant move forward, right? It's that 3 years down the road, how do you do the migration to get your infrastructure moved over? We think I guess it's a couple clicks to add each one, a couple clicks to remove each one, and you're done. Is a whole lot better than the weeks of planning and consultants that have to be hired to execute all that. I apologize to all the consultants who spend their days doing that. So at the very core of what we do, and this is usually the thing we start with, but we left it towards the end, the data virtualization engine. So this is dedupe compression optimization. Dedupe is obvious, right? Compression is obvious. I talked about one of the areas of optimization, which is the ability to just pop the vSwap file out of that so you don't capture it in a backup, you don't replicate it, you don't move it to the cloud. It's not useful. The key for us is we wanted this to make everything faster. The classic problem with deduplication is it was designed originally to solve a capacity issue, right? It was designed for backups, and the objective was, can we deliver throughput, and can we optimize the capacity of this device? That's absolutely the wrong problem if what you want to do is put this under your VMware infrastructure. Our objective was to optimize for low latency and high IOPS. Completely different set of deduplication technologies than historically the market has looked at. So yeah.
What is your key?
Sure, so it's a great question. So what we tend to talk about is 25,000 IOPS per OmniCube. However, we just published a benchmark that was 40 OmniCubes in a data center, delivering 1.2 million IOPS, which we're pretty excited about.
Do you have a per volume limit?
We don't, no. It's not, you're more likely to run into VM limitations if you don't put the pair virtualized drivers in there, and if you don't have, there's a bunch of games you can play, right, to make sure you get more IOPS out of your guest. We actually find customers tend not to do any of those things, and those are the biggest boosts as opposed to a volume limit for us.
Can I recommend that you change that benchmark slightly? Instead of 1.2 million IOPS, can
Sure.
you call it, please, 1.21 mega IOPS?
Yeah, so we are pretty excited about it. We probably haven't been loud enough about the fact that we did that. It is a pretty big number, and we thought it was pretty exciting. But the goal there was to show 2 things. One, it actually delivered us significantly more than the number we tend to talk about, which is 25,000. But the other aspect is you just...
Yeah, that's significantly more than 25,000.
Yeah, that was...
It's 30,000.
It was to show the linear scale of it.
Well,
it's true.
That is the math. Which, in fairness, is significantly more than 25,000. So I think everyone's right on that.
So as you're approaching your limit, where's the current
I'm sorry, I just did the math.
As far as, is it CPU, is it memory, is it this, is it that? Yeah, so the current limit in the system is actually CPU usage of the virtual machine. It depends on the workload. So sequential is going to be different from reads and writes for random. Yeah, so of our virtual controller.
Do you currently support any type of QoS or plan?
Yes, so great question. We don't today, but again, it's a logical thing for us to add to the platform. The way the system's designed, we can see the virtual machines. We can see where they're doing their I/O. If you manage that properly, QoS should be a logical add-on to that, right? Yes. Yeah, so we wouldn't be able to deliver those IOPS if we were not multi-threaded within that environment.
How far do you scale? I mean,
how far do you want to scale? So
a billion.
All right, so that's a perfect way to make sure I say. So
they haven't raised enough venture capital firms
exactly
to buy that money to test.
Okay.
So yeah, I don't have enough lab space to test a billion systems. What I can tell you is that we're talking to telcos who are talking to us about scales of tens of thousands, approaching hundreds of thousands of systems. And effectively, we're testing to meet the requirements of our customers. We just added an extra, I think, 10 or 12 tons of air conditioning to our lab environment to continue to support the ability to test bigger and larger environments. It's a question of...
For practical purposes, isn't there a 32 limit?
Well, there's a 32 in a cluster limit within the environment today. So when we tested 40, it was actually 2 clusters. But that's not our limit. That's just a...
Yeah, it's VMware.
It's a VMware limitation.
Have you identified at any point where scale would start to break down?
No, so the system from day one was designed for telco scale. That's not where we decided to go day one. We went to start talking to mid-market customers initially, and we think of mid-market as 50 to 1,000 VMs with core business applications, right? Exchange, Oracle, SQL, SharePoint, the core of the data center. However, from an architectural perspective, the objective is to get this to telco scale. So the core architecture is there today to get us there. The question is, how many nodes can I fit in my lab, and how fast can I test those systems? So to accelerate that process, for example, we've designed what we call a federation in a box. So we put a whole pile of ESX boxes on top of one physical system so that we can fan out the number of systems we simulate at the same time. That allows us to just fit more gear in our lab. We test everything on physical, but that gives us a nice environment to do testing on.
Can you elaborate on how you do the deduplication, compression, and all inline, and still not losing everything?
Sure. So that's back to the slide, and I'm happy to talk about that. The objective here was inline. And there's critical reason for that, right? If you don't do it inline, you're not saving the hard drive IOPS. At the end of the day, the hard drive IOPS are an incredibly limited resource. We've all seen the charts that show hard drive performance that does this, and hard drive IOPS that are, sorry, let's do that the other way around. Hard drive performance that's totally flat, and hard drive capacity that's on this ever-increasing curve. If we rewind the clock 10 years, we were looking at the exact same chart, except it was 36 gig drives instead of 3 terabyte drives. The performance hasn't got any faster, but the drives are now 100 times bigger than they were a decade ago, plus or minus. From that perspective, the core focus is how can I save IOPS to those hard drives. So I talked about the dedupe example for boot storms earlier. Same thing for being able to write data into the system. If we can eliminate that write before it hits the drive, that's a major win. So deduplication makes us faster. Not intuitive and not the question most folks ask, but it makes our system faster. We found this great quote.
It also boosts the SSD life.
Yeah, so reducing IOPS and reducing writes to and I/O to the SSDs in general makes your SSDs better as well. Your level of flexibility in the SSDs is a little bit greater than the hard drives, right? If I miss by 10% on an SSD, it's not as big a problem. If I miss by 10% on a hard drive, I can't deliver the I/O. The system just isn't fast enough. There's this great quote, actually, we found somewhat recently from AMDAL, where folks may be familiar with, I wasn't, which is the best I/O, or the fastest I/O in your system is the one you don't have to do. The best I/O in your system is the one you don't have to do. We should have actually found that when we founded the company, because that is really the core of the approach we've taken to deduplication. Prevent yourself from having to actually do the I/O to the drives. And that ripples through. Because you do that in real time, your replication doesn't have to worry about, well, did I have time to deduplicate the data that was on disk before I replicate? Those issues all go away. So had to be real time, had to be high performance, had to be at a fine grain level. We didn't want to be moving megabytes of data into cache. By the way, when we talk about cache for our flash layer, we cache that data, again, to preserve hard drive IOPS. If you tier it, you bring it up, and when it cools off, it goes back down and hits your hard drive, which defeats the purpose of eliminating those hard drive IOPS. Had to be once and forever. Deduplicate it once, compress it once, and keep it in that format for its entire lifetime. No matter where you move it between DRAM, flash, hard drive, the cloud, between data centers, back and forth to the cloud, always remains in this format. The key to being able to do this is the OmniCube accelerator. So every OmniCube system has a PCIe card in it that's part of our IP. This is not OEM from some flash manufacturer, some chip manufacturer. It's our IP. We have a hardware team that develops and builds this. This is what enables us to do all this and still leave you plenty of CPU to run your applications. Right? There's a tremendous amount of overhead that goes into deduplication and compression. To be able to do all of that work and actually have a net result of making your system faster, that's the OmniCube accelerator. That's basically the nitrous in the system.
Is the cache in the SVT?
Is the cache, so the cache is multiple places. There's DRAM inside of our virtual controller. There's a SSD in the system, which gives us access to flash, and then you effectively get cache in both places.
How does your system handle different types of disk allocation sizes, like bigger block sizes?
Yeah, so we break down, right? If we get a giant block, we break that down because it turns out that large blocks, if someone writes a megabyte, actually ESXi is going to break down those bigger ones, and most guest OSs are actually going to break down a lot of those larger ones as well, right? By the time it gets to us, we are the data store, so it's already been chopped by the host, it's been chopped by ESXi, and then we get it. Most of them actually aren't that sizable, but we do break them down so that we can deduplicate them more effectively. What are the other questions? Around this core, I call it the flux capacitor. Marketing doesn't necessarily love that. But without this, the rest of it just doesn't work.
Well, how else would you get 1.21?
There you go. Actually, that's what we should publish. Is it really 1.21? I think it is, isn't it?
It should be.
That's brilliant.
That's close enough.
It was gigawatts, not megawatts.
It's 1.21 gigawatts.
It's 1.21?
Gigawatts.
Yeah, that's perfect. So we should definitely, we can do 1.21. So that's actually a perfect slide. So yeah, this is the core that
You didn't get that before, Jesse.
Yeah, so I used the Back to the Future reference, but I didn't take it all the way to gigawatts. That's a step further. We'll credit you for that, though, Stephen. So the rest of the things we're talking about really wrap around this, right? This is the core that makes everything else possible. So we talked about three things.
So do you put like a flux capacitor on the front of it?
No, but actually, you know what's kind of cool? When you look at this, that's basically an upside-down flux capacitor, right? Didn't the flux capacitor it came in like this and had one on the bottom? So in retrospect, we should have turned this 180 degrees to try and get it at the top. But
Produce another line that is just like the bling for your OmniCubes.
That would go well with the cube-shaped OmniCube.
yeah, so the cube-shaped. So you're not the first person to recommend that we make a cube-shaped. I actually think Hans might have been the first one. Hans wanted us to make an OmniCube out of the old Mac cube, which I actually.
No, what a piece of crap.
No, it was a piece of crap. But how brilliant is it that it's a cube? Unfortunately, it's PowerPC based. I was going to go try and build one, but it's PowerPC based, and it just.
Swap out the board.
We could fit one in a shuttle case that would be.
That is true. We could get it shaped like a cube. So the front of our bezel has a little three-dimensional cube on it. I think it would be brilliant to have actually a little flux capacitor there. It turns out that one of the current defects in our product is that there's no power on the bezel, which means we can't light up the bezel. So it's an active project that I'm very anxious to solve because I do want it to light up.
I want mine to have two cubes on top of each other and a little glowing siren on top. No blue.
Send me an email and we'll submit that to engineering as an RFE.
The look on Rob's face. You make a Doctor Who joke, and he goes, no.
Well, it does have more space inside.
Yes, it is bigger on the inside than it is on the outside.
That is true.
I just don't want to be the one being deduplicated.
So we talked about really three core things, right? The first is marketing. Virtual resource assimilator, right? Everything needs a name, so the virtual resource assimilator. Effectively, this is the single shared resource pool. This is.
So you guys are more board cube. Yeah.
Yes, we have more. The Federation was the start, and then the rest of the Star Trek analogies just sort of fell out from there. So yes, the virtual resource assimilator. I think we have you will be federated or you will be assimilated stickers. What are they? You'll be federated. You'll join the Federation.
Technically, they fight the Borg, but
you just don't put logic and technical rules on top of the.
On top of sci-fi.
Yeah.
So then you need the one with the helmet, the eyepiece on top.
Someone was in our booth with Google Glass yesterday. We could have taken pictures and had the whole Borg thing. So the first is the single shared resource pool, right? So this is the idea of getting rid of these islands. We got rid of the islands on the server side. Let's get rid of the infrastructure islands. So the business applications have been shared horizontally and created we created a single shared resource pool there. Let's do the same thing for the infrastructure applications. The accelerator we just finished talking about, real-time, fine-grained, once and forever, right? Through all the tiers of the system, save the IOPS, save the WAN bandwidth. Yes, we save hard drive capacity as well. That's fine, but not the primary objective. And the global federated architecture, this is scale-out, scale-in, VM-centric policy that allows you to abstract the policy completely away from the underlying infrastructure. all managed through Vcenter. All right, so this is the slide that has never been seen outside of SimpliVity engineering before. That normally I whiteboard, but I figured I would put it up as a discussion point for those who inevitably had questions about. So the first thing you do is take a picture and tweet it. If someone wants to see it, at least make them watch the whole TFD video to see the picture. So this is the high level of how our system. No, I wasn't kidding when I said this doesn't go outside of engineering. So I would rather if we made people watch the whole thing, but. So this shows our virtual controller. It shows ESXi. It shows the hardware sitting underneath. It shows a Windows virtual machine, a Linux virtual machine. And one of the questions we always get is, well, basically, how does the I/O go through the system? Gabriel, why are you taking pictures of it?
Because he doesn't even have the slide.
So, you know what? He doesn't. This is probably the first time he's seen it, actually.
He just said it was. I said, this is the first time I've seen it. He said, yeah, I haven't seen it either.
So we got the feedback. You guys wanted content that we don't normally share. So this is content we don't normally share. The question is, what's the I/O path, right? Where does an I/O go from a guest? The virtual controller shares out an NFS connection, which is the data store. Every OmniCube shares that data store locally. So the OmniCube is sharing data store 1, let's call it in this case. That contains VMDK files. Those go up as virtual devices to the virtual machines above it. We get this I/O through this path, right? It comes down. It's really weird being that close to the projector. The I/O comes through the file system, through the block interface, down into the VMDK. It gets pushed over to us via NFS. It comes into the virtual controller. The virtual controller does two things with it. It sends it to its favorite neighbor, because you need to commit it on a separate system. And it sends it down to the OmniCube accelerator locally. As soon as it hears back from the OmniCube accelerator locally in the remote system that it's been committed, it acknowledges back to the ESXi, and you continue.
You're actually missing the V switch.
Yeah, it's not perfect. It's a simplification, but I appreciate, Ed, that you found the missing V switch in the.
Well, it's also you got the V switch, then you got inside of the storage path, you got the V SCSI information that could actually interfere with it. A lot that's missing from that picture.
This is not the diagram of our infrastructure that engineering builds the product based on. Have no fear.
That one's on a napkin.
Yeah, exactly. We framed a napkin. It's all good.
And
so
the labels are in Hebrew.
Yeah. So talk to the OmniCube accelerator, acknowledge back. So it's done. It's committed on 2 systems. The VM moves over. Right. Again, the objective there is to lower the latency. All of those I/Os are going to go out to the hard drives. They don't go to flash because most I/Os that were just written actually don't get read immediately. The idea of using your flash to write every single I/O to your system goes back to Howard's point of the less I/Os you do to your flash, the longer it lasts, the more efficient you can become. So if you look at storage systems, recent writes are actually very seldom reread immediately. So in our system, you serialize those, and you write them out to the disk in full stripe writes. Get the data out to disk efficiently, get it down to the drives, free those drives up to do something else.
What's the best latency you're seeing with the shared sort of data for the other cubes and then the acknowledgement back?
So the performance, so I have a number off the top of my head because I just did it yesterday on the floor for somebody as part of a demo. We did a boot storm of 30-something VMs just in one of our the OmniCube data centers we have. And we were seeing 15, almost 16,000 IOPS at 0.2 milliseconds of latency in that environment. And the writes were lower and the writes were less than a millisecond. I think they were 0.7 milliseconds in that demo. Yeah, so yeah, the more deduplication of your data, the better, right? If in the end of the day, if we're going to hit a hard drive, there's still we haven't fixed the laws of physics, right? The hard drive's still spinning at 7,200 RPM, and
but it's at the end of the day. We're going to drink by the end of the day, so
we're going to drink by the end of the day. Is that what you said?
It's by the end of the day.
Yeah. Right. So on average, you're going to have to wait for half a rotation if you have something that wasn't in the flash tier, it wasn't in DRAM, and you had to go get it from a hard drive.
So typically, disks are attached, almost directly to the data store in an environment with a little bit of latency there.
Yep.
How much latency does your path add?
Just coming up through the guest. So those numbers that I was talking about are actually measured at the guest side. So if we watch our latency through Vcenter, we don't see a big discrepancy there. We're going through an internal hop in the system, and the code path to get you your I/O is where all the optimization is, right? That's designed to be as efficient as it can be.
Okay, your example does include the cached part, right? But not actually disk access, so that's why.
Yeah, although the latency of the stack is the least of the problems when you have to hit the hard drive, right? The latency of the hard drive is going to dwarf any latency introduced by the stack. And so we're more concerned actually with the latency. It's the same, by the way, the latency of our latency hitting a hard drive and our latency hitting a disk drive, or sorry, a flash device, is effectively the same. It just happens that the latency, our latency is a sizable or larger proportion when you hit flash as opposed to hard drive. And the hard drive, anything we add is noise compared to hard drives do millisecond access, right? So, but it's optimized to make sure that we're getting low latency even when it's coming off of the SSD tier.
Excuse me, a quick question.
Mm-hmm.
I didn't catch how you manage configuration with I understood that you have pairs of nodes, favorite neighbor, you said, and you copy data on the second node.
Yep.
But you have 3 or 5 nodes. What happens?
Yeah. So we have words. I cringed at words folks used earlier to describe us. We stay away from the word pair as well. Pair implies that you add 2, and then you add 2, and then you add 2, and you add 2. You just add them one at a time into this environment. So we don't pair OmniCube 1 and 2 and OmniCube 3 and 4. It's much more dynamic than that. The OmniCubes have partners that they don't necessarily partner 2 OmniCubes for every piece of data on that system. One OmniCube might be sending some data to node A, B, C, and D. So it's much more dynamic than that to design to keep the system in balance.
Do the nodes know proximity to other nodes? Do they keep track of that? So if you have 10 nodes in sort of a row and they're all jumped, do the middle nodes know that the next adjacent nodes are the ones that you're talking to versus the far ones?
So in our environment, within a data center, we assume high connectivity. We assume within a data center, everybody's got a 10 gig connection. And across data centers, we absolutely know that those are a slower connection. So at that level, we certainly differentiate. But when we talk about deduplication, even at a global level, we're never going to take and deduplicate some bit that belongs to a virtual machine in data center A out of data center A. Right? If there's a VM in data center A that's using some bit of data, we're not going to say, well, go get it from data center B. Right? From a latency perspective, it's not a viable.
So it's very coarse.
As long as you're on the same switch backplane, it doesn't matter which order the ports are in most of the time. You may have paired ports in a switch that are on PHY or something, but it's not like port 3 has to go so much farther to get to port 6
Correct.
on your switch.
We're not doing microsecond measures to make sure that we have that.
Are your SSDs SAS connected or PCIe?
They're SAS connected. So from our perspective, we can use the overall architecture is designed to be completely portable. So portable between hypervisors, portable between platforms, portable between clouds. From an underlying platform perspective, we think the most cost-effective and most performance-effective way to get flash today is in the form of SSDs. Technologically, I could unplug the SSDs and plug in a PCIe card and leverage the PCIe card. We don't think that's the most effective way. In the end of the day, if you have one PCIe card in your system that you're dependent on, we'd rather be able to do RAID across the drives in the system. There's a reasonable failure in flash components these days still, and we'd rather make sure that we can protect against that.
And at least for writes, you've always got the network latency on the synchronous replication, so that the lower latency of PCIe isn't going to buy anything.
Yeah, so in storage, I think there's a lot of propaganda about whether it's faster to go to an SSD or whether it's faster to go to a PCIe card. If you're in the HFT market and you're doing high-frequency trading, those guys care about the microseconds. And in the real world, then those metrics are, for business applications, I think they don't really matter.
In your writes, you actually have the ACK already back before you're writing it down.
Yeah, the ACK comes back as soon as you hit the accelerator.
As soon as it hits the second.
As soon as it hits 2 accelerators, correct, Hans. Sorry. Other questions? My clock is ticking, so. Yeah.
I don't know how far off this is from being mainstream retail, but do you guys see yourselves doing like the front load NVM flash? I've seen some of that sort of in demo models from Dell and HP.
Yeah, so are you talking about the...
PCIe, but in a block module rather than a PCIe card.
Yeah, so I have to walk a fine line of, I'm not sure who has publicly released information about that technology and who's not. I think very few folks have, but it falls into the same exact category for us. We could flip a switch and take advantage of 2.5-inch PCIe attached devices as well.
Okay.
There were a couple others I saw.
If I heard well, you launched the second model of OmniCube.
Yeah, last week.
Last week, and can you mix and match the two models in the same federation?
Yes.
Last.
Yep. In fact, one of the very common use cases for those is that we released last week, for folks who haven't seen it, we call this product the CN3000, which is the no, it's not, sorry, we didn't get to the demo. In the booth, you can come see us and you can get a demo. The CN3000 is the platform we've been shipping. We announced the CN2000, which gives us the ability to run lower capacity, lower CPU, and it's a less expensive entry point. And then what we got was...
Same accelerator? Or?
Yeah, so the same core building block, the same components, same exact software, looks and feels the same. And then we went up market. We had customers asking for SAP in these high-performance Oracle environments. So we went to a system with 24 2.5-inch drives to drive up the performance on those systems as well. So one of the common use cases we're seeing for the CN2000 is when you think about the simplicity of backups in our environment, where you can apply a policy to all your VMs. Think about branch offices for corporate environments, the ability to push that data back into a centralized environment, deduplicated, compressed, and optimized. 2000 is on the edges, 3000 is in the middle. It's a great use case. And I'm in the red. I just have like 5 seconds.
So does this thing actually self-heal if, say, for example, some engineer, admin goes in and misconfigures your NFS to the NFS network so that you can't no longer talk to the BMK because they've actually...
That's effectively the same thing as taking a sledgehammer to a box, right? If I delete all the network connections in the environment. So what is... so be more specific than what we were asking.
The VNet for the SVT.
Yep.
And the VMK, the VM kernel for NFS have
yep.
to be the same broadcast domain. If I change that, it don't work.
Sure.
How
so
does the SVT prevent that from happening, or look for it and detect auto failure and resolve it, so I don't have to worry about it? So
if the local virtual controller loses the ability to communicate with the local data stores, that's
data stores.
Right.
I'm talking about the SVT.
Yep.
Is sharing up NFS direct to the host.
Right. So when I was saying data store, that's from we share NFS to ESXi. So if you disconnect that somehow, and
it's easy to do, just change the VLAN IDs. That's
sure.
Gone.
So when those two things can no longer communicate with each other, one of the other virtual controllers within the environment will actually learn that and will actually take over communication with that ESXi.
Self-heal.
Yeah. So there's one data store across this environment.
No, I mean, will you self-heal the one that failed?
No. So am I going to go fix the configuration change that you made?
Yeah.
No. You
should. That's
yeah. So us being in the business of changing something that a user just did, that's not a good plan for our users to be happy with us.
So you are saying that once it's deployed, no one can ever touch it anymore? Because it's going to self-heal?
No, that
because that's the problem. If you're going to want to change something in the system, migrate VLANs, you're not going to do it if it's self-healing.
We can't argue with the user.
A system that says this has been changed and made this part break, and here's where to go to fix it.
But how do you know it's broken?
Sure.
But isn't that more of a vSphere
But
construct?
no, vSphere doesn't do that at all.
Well, no, but I mean,
but shouldn't it be vSphere's responsibility?
Exactly.
Yeah, right.
No, actually, I don't think so.
I think it should,
Because
it's a
this
bigger
app,
problem than
because
just
this app depends on it. That's what I'm saying.
But how do you
We continue to provide data services, which is what's in our power. It's not viable for me to go to a user and say, you just took an action and I think I'm going to change that on your behalf. Not a good...
broken.
vSphere
I mean,
actually
it's
does do
different
that
things
with the
with different people.
distributed switch.
It's true, VDS it will move stuff, yeah.
Roll back.
I'm past the red zone now. So thanks, everyone. I appreciate it. This has been good. Hopefully this was useful for everyone.
Thank you.